Hello chemistry people, Amy here. What I've got for us today is a discussion of topic 8.5 from the SL chemistry curriculum, looking at acid deposition. Before you get into this video, if you aren't familiar with the pH scale, strong and weak acids and bases, and some indicators maybe, reactions of acids and bases, you need to go back and review those because I'm going to be taking that information as known. Today I'm going to be talking about acids and bases in the environment and how humans have been messing with that, basically. So give me a second while I pause and change over to my OneNote so I can take some notes for us. Okay, so as always, we start with our study guide, and I am going to be going through and covering off these points. The first one for us to start with is a discussion of what do we mean by deposition. So deposition, and acid deposition in particular, is where these chemicals are deposited from the atmosphere. Most of what we're going to be talking about today is acid rain, but we can also have like acid snow or sleet. And we can also have acidic ashes. So if like powdery flakes of acid come from the sky, that is acid deposition, it isn't just acid rain. Having said that, let's now focus on acid rain. You need to know that deposition isn't solely acid rain, but for this topic we are mostly going to be talking about acid rain. So carbon dioxide. So CO2 is a completely natural component in our atmosphere. Carbon dioxide's been in our atmosphere for longer than oxygen has. So carbon dioxide, when it goes up into the atmosphere, can dissolve in water that's present as droplets in clouds, and it can form carbonic acid, H2CO3 aqueous. Now so my carbonic acid can then donate two protons. And those are both weak. So, having slightly acidic, and remember what acidic means. So having slightly acidic rainwater is completely natural. So it's not raining at the moment, but it's forecast to later today. So if I went out and collected a container of that and then measured its pH, we would normally expect rainwater to have a pH of approximately 5.6 at its lowest. So, for something to be called acid rain, it's rain with a pH that is less than 5.6. Okay. So, humans have contributed to acid deposition by increasing the amount of CO2 in the environment, absolutely. But we're going to be focusing on some of the other chemicals that we've added to the atmosphere. So the first one comes from sulfur. So biology people will be able to tell you that all living things have, as part of their protein structures, cysteine as one of the amino acids. Cysteine's special because it contains a sulfur that is able to form disulfide bridges in proteins. That's something that chemistry people will discuss when we get into biochemistry, if we do that option. So sulfur is something that naturally occurs in organic compounds, so biochemical compounds, I should say. And this is an issue because when you look at coal, oil, and gas, mostly coal and oil, these guys contain small amounts of sulfur. Now, because sulfur contamination of the environment, so because sulfur is mostly found in coal and oil, in order to limit the amount of sulfur that goes into the atmosphere, we need to control, this is all about power generation. We're not talking about like something that we individually can do. Sulfur is a power generation issue. So what happens? I basically, in my coal, have solid sulfur, which I can then burn in oxygen as I burn my coal, and it makes sulfur dioxide gas. Now, there's two things that can happen. Version 1, I take my SO2 gas and it gets up into the atmosphere and it reacts with water and it makes sulfurous acid. Oh, be good if I could spell. Sulfurous acid. The other thing that can happen is if I have two SO2s and an oxygen, it can react to form two SO3 gases. And remember, we're in a power station where we are burning stuff all the time. It's very hot, which of course makes it more likely that reactions will happen. Remember kinetics. That looks like 803, SO3. So once I've got my SO3, that SO3 can react with water in the atmosphere and form H2SO4 aqueous. And this is sulfuric acid. So, sulfur contained in coal and oil can create both sulfurous and sulfuric acid. Now, one of the ways, so I can control this in two different ways, and it depends on when I want to control it. So I can either control the amount of sulfur by doing what's called precombustion. So that's basically taking my coal and then removing sulfur solid from them. The main way we do that is by, so you just need to know that precombustion is Precombustion is one of the methods that we can use to remove. Most of the time, the precombustion methods using a whole bunch of complicated like steps of the reaction and catalysts that you don't need to know. Basically what happens is we take the sulfur and we convert it into hydrogen sulfide gas. This is rotten egg gas. And then we can convert that into sulfuric acid, aqueous or liquid. Now, the issue with the sulfuric acid that we generated with my green equations up in the atmosphere, we can't control that, so we can't collect the sulfuric acid. Sulfuric acid, and you'll see this when we get into organic, is a really important industrial chemical. So we all have, or most of us will have, a fair amount of sulfuric acid, like within our garages. So the batteries that are in most petrol engine cars are lead acid batteries. The acid in those batteries is sulfuric acid. Sulfuric acid is also used in the manufacture of every single like artificial flavour for reasons that, again, we will get into when we look at organic chemistry. But sulfuric acid is a really important industrial chemical. So this sulfuric acid, removing it pre-combustion, is helpful for like keeping the sulfur out of the air, but it's also helpful in terms of like generating this industrially useful chemical. So that's pre-combustion. There's then post-combustion. And this is where I take the SO2 gas and remove it from the mixture of gases coming out of my power station. So how I do that, I react that with, calcium oxide. And just like the other one, you don't need to know exact steps, but I end up making calcium sulfate. Now, calcium sulfate is one of the main components in plaster. So again, just like I can take the extra step beforehand and get rid of sulfur, and I can take the SO2 out afterwards and make plaster. Those products, when I take those environmental steps, are economically helpful, which adds a certain impetus for companies to take these steps. If it was just you have to do this extra step and it's expensive and you don't get anything back from it, there's a lot more pushback to that than, hang on, you'll be able to sell the sulfuric acid, you'll be able to sell the plaster. So that is sulfur. Let's now talk about nitrous oxides. So let's talk about NOxes. So NOxes, actually I'm going to switch colours. So earlier I did an equilibrium experiment where I made nitrogen dioxide, NO2. Now NOxes, named because they are different oxides of oxygen, different oxides of nitrogen, sorry. It isn't just the one compound that's formed, there's a range of different ones. So, inside the internal combustion engine of just a normal car, what that is it's a series of chambers, and for anybody who is watching this who knows more about cars than me, congratulations. But I am trying to teach this from a chemistry perspective. So, okay. So you might have heard of a car being described as 4-cylinder or 6-cylinder or 8-cylinder. So a cylinder is one of these things. It's basically a piston inside a strong metal container. The fuel then gets injected and then it explodes. That explosion pushes the piston up, which transmits the energy to the engine. So inside here, I'm dealing with high temps and high pressures. Now think back to kinetics. This is a recipe for getting a whole bunch of reactions to happen really quickly, which is awesome if you're trying to explode petrol to make an engine go. But it can also take nitrogen gas, which makes up 80% of our atmosphere, and I can react it with the oxygen gas that makes up 20% of my atmosphere, and it can make two nitrogen oxide gas. Or I can have nitrogen gas reacting with 2 oxygen gases to make 2NO2 gas. This is the nasty brown stuff that I made in my experiment video. So once, and I can also have nitrogen monoxide reacting with oxygen gas to make 2NO2. So what does my NO2 do? I can have 2 NO2s getting up into the atmosphere where they react with water to form HNO2 aqueous and HNO3 aqueous. So this guy here is called nitrous acid. This guy here is nitric acid. So nitrous and nitric acid are both acids. Duh, it's in the name. So these guys all contribute to acid rain. So the acids that contribute to acid rain are sulfurous acid, sulfuric acid, nitrous, and nitric acid. So some of it is coming from internal combustion engines. So some of that is coming from internal combustion engines, and others is coming from power generation. So let's go back and look at our study guide and see how we're going. So we have talked about rain being naturally acidic because of dissolved oxygen. We've talked about the formation of the nitric acids and the sulfuric acids. we need to talk about the effects of acid deposition, but we've discussed the sources of sulfur and oxygen oxides. We have looked at combustion of sulfur and nitrogen, and we've looked at those equations there. We've distinguished between pre-combustion and post-combustion. And this effects of acid deposition, we're going to look at how it reacts. So, acid rain, and I'm guessing you can work it out just based on the name, it's not something we're kind of aiming for. Like, it's not a good thing. So, acid deposition, acid rain, we can see effects of it in various places around the world. One of the main things is we see it on buildings made of limestone. So calcium carbonate, hang on, is calcium carbonate limestone? Excuse me a tick while I pause and double check. Yes, so limestone is calcium carbonate. So one of the main effects is that calcium carbonate reacts with the acid and it actually wears down. So things like buildings and statues. So a lot of the time when you Google image search for effects of acid rain, you will come up with things like the fountains in Rome that have been, yes, weathered by rain and other natural effects, but have also worn down quite substantially because of the interaction, so with the acid rain. Sorry. So in addition to reacting with the buildings, another thing that can happen is we can react with iron and other metals. So we can have metals reacting with the acid rain. Now, these reaction types are ones that were covered in that earlier video, so I'm not going to spend much time on them. One of the other things that can happen is that acid rain has a variety of effects on plant life. Biology people think back to denaturing of proteins and how concentration of acid can affect denaturation. Another thing that can happen, as I change the concentration of H+, I change the solubility of various important ions in nature, such as magnesium, calcium, and potassium. So if I increase the solubility of magnesium in my soil, less of it will get taken up into my plant, and magnesium is part of photosynthesis. So as I change my concentration of H+, I'm going to change the solubility of certain really important ions, which can lead to the plants not developing properly. Another thing that can happen is if I have like aluminium hydroxide, that's a solid and it's reasonably stable. But if I react that with acid, what happens is I end up with a free aluminium ion and water. Now, this aluminium ion interacts with the oxygen exchange by memory in fish gills. So the aluminium, it's not something that's toxic to us. It's not like mercury or something like that, but it interacts with the gill. I believe it's the oxygen exchange in the gills of a fish and stop them from being able to breathe. So yes, I mean, and yes, there are effects on humans, like it eats away at our buildings, it changes the way we can grow and manage food. But we can also, if you're in a particularly acidic area, it can cause irritation to the eyes, to the nasal mucosa, so the soft skin on the inside of your nose. So we've talked a bit about how we can manage this. So pre-combustion and post-combustion with sulfur. Oh, sorry, I missed it with my NOxes. What can we do to manage NOxes? Two main things. So we can use what's called a catalytic converter. So in a catalytic converter, what we have is catalytic converters are used to manage actually two problems at once. So it takes very toxic carbon monoxide gas, which is also produced as part of combustion in internal combustion engines, and it mixes it with the nitrogen monoxide gas, and it makes CO2 gas and nitrogen gas. Now, carbon dioxide gas isn't great from a global perspective, but it is better than carbon monoxide and nitrogen monoxide. It's safer for humans. The other thing we can do, as I said, one of the dangers, one of the things that causes this in the first place is that we are dealing with high temperatures and pressures. So what if, instead of running an engine at higher temperature, what if we could have low temperature combustion? If we decrease that temperature, that reaction is less likely to happen. Okay, let me just double check that we've done all our points. So we've talked about the sources of the oxides of sulfur and nitrogen. We've talked about the effects of acid deposition. So ka-ching. And we've talked about, so this deduction, this comes from the video I did for, I want to say 8.2, for the reactions of acids and bases. Go back and review that because the IB do like asking questions. Okay, thank you so much for that. Have a fantastic rest of your day and I shall see you next time. Bye.